Good morning. Here's our lesson 4, pages 102 through 103. And at the top of the page it says prime numbers and composite numbers, which I'll explain in just a sec. Let's show our mini boss. Can you find a number with 8 factors? What's the smallest number with 8 factors that you can find? So if you know what factors are, you can give this a try. Otherwise, we'll come back to it at the end of the video. All right, here we go. So, introduction to prime numbers. Prime numbers have only 2 factors, 1 and itself. So, like the number 3 has 2 factors, 1, 3, nothing else is a factor, so it's a prime number. We'll do more examples, it'll make more sense, I think, with examples, but composite numbers then are everything else. If it's not prime, it's composite. And if it's not prime, it has more than 2 factors. So we'll do some examples. It's a lot easier with examples. Oh, here I can leave that. I can leave that. Here we go. Is it prime? Okay, so a prime number will only have 2 factors, so a great way of finding if it's prime is to list out the factors. So 3, we have 1, we have 3, 2 can't be a factor because 2 times something doesn't equal 3, at least 2 times a whole number doesn't equal 3, so we've just got 1 and 3. So it only has 1 and itself 3, so it's prime. All right, for 4, let's list out the factors. Pause the video, take a sec, see if you can list the factors. I hope you do, or at least try it in your head. So we have 1, we have 2, we have 4. It has 1, it has itself, but it also has another factor, so it is composite. It is not prime. All right, go ahead and try 5. Hopefully you could pause the video. So you have 1, 2 is not a factor, 3 is not, 4 is not, 5 is, and now we're up to the number 5, that's always the last factor. So we have 1 and 5, so it's prime because it only has 2 factors, 1 and itself. Okay, let's try another. Is it prime? Go ahead and pause the video and try all these. List out the factors and then say if it's prime, yes or no. So I hope you tried it. So for 12, you should get 1, 2, 3, 4, 6, and 12. It is not prime. For 13, you should just get 1 and 13. Yes, it's prime. For 2, you would get 1 and 2. Yes, it's prime because it's just 1 and itself. We'll do one more set of examples here. Is it prime? 14 and 1. Go ahead and try both these. And hopefully you tried it. So you'd have 1, 2, 7, and 14. So it's not prime. And 1, we just have 1. So mathematicians had to debate this one. Is it prime? It only has 1 and itself, but 1 is itself. So it's actually not prime. 1 is a really weird one. It's not prime. It's also not composite either. 1 is a special snowflake. I say that because it is the only one of its kind. It is so wonderful. Mathematicians think 1 is very special. And being neither prime nor composite is just one of its many special properties. So, our mathematician's favorite number is not prime or composite. Okay, let's go to part 2. All right, this time it talks about multiples versus factors. So it's kind of a little bit different terminology. I think really the easiest way to explain this is to give examples, which is why I have these equations here. So here in this, 2 and 3 are factors of 6, as we've been talking about. 4 and 5 are factors of 20, because you can multiply them times a whole number and you'll end up with 20. 3 and 3, factors of 9. Now let me get another color here. Now here, what do we call this? Well, it's the sum. It's the it is the answer when you multiply, but this is a separate term, I guess. So 6 is a multiple of 2, and it's also a multiple of 3. That means that you can multiply 3 times something and you'll get 6. You can multiply 2 times something and you'll get 6. Okay, here 20 is a multiple of 4 and a multiple of 5. 9 is a multiple of 3. One thing people like to point out is a number has endless multiples. If you want to list, let me see if I can get a blank layer for us here. Well, that's okay. If you want to list multiples, you could just, the list could just go on and on. Multiples of 3. Okay, so you could say, 3, 6, 9. Okay, because that's 3 times 1, 3 times 2, 3 times 3, 12, 15. You could have 300. You could have 303. You could have 306. You could have 3,000. The multiples go on and on. There are many, many multiples. So many. Factors, I'll just put this on the same page. So factors of, let's say we have a factors of 12. There's a limited number of factors. There's 1, 2, 3, 4, 6, 12. That's all the factors. You can't think of any more factors. So there are few factors. So one way of remembering that is to say many multiples, few factors. All right, let's go to the next exercise. Okay, now we're going to figure out if something is a factor. We've kind of already done this, so this should be not super hard, but a good review is 4 a factor of 16. Go ahead and try that one. Okay, so you can say, okay, 16 divided by 4 is 4. it goes in evenly. So yes, 4 is a factor of 16. Go ahead and try B and C. Pause the video if you can. Okay, is 5 a factor of 16? You'd say 5 times 3. It's not even. There's going to be a remainder. So no, 5 is not a factor of 16. Is 10 a factor of 1,000? So you can go ahead and try that. Well, you'd end up with, there's no remainder. So yes, 10 is a factor of 1,000. Okay, now we're going back to multiples. Is 15 a multiple of 3? Well, we can also use division to find this. There's a couple different ways you can think about it. They're asking, is 15 the answer if you multiply 3 times some whole number? Well, yeah, you can do 5. So it is a multiple. Another way of figuring that is to use division. So 15 divided by 3. Does 3 go into it evenly? Yep. So 15 is a multiple of 3. Is 15 a multiple of 4? So 15, we'll see if 4 goes in there. 4 times 3 is 12, so we're going to have a remainder. So no. Is 32 a multiple of 4? So let's try dividing. You can always pause the video and try it. Well, 8 times 4 is 32. So it's even, so yes. All right, on to the last part here. Using division to decide, is it a multiple? Which we already did in the last page, I guess. But these are a little bit bigger numbers, so let's give them a try. Is 98 a multiple of 4? So 4 times, oops, better click on this. There you go. Is 4 times something 98? So we can use division. Here's where long division can kind of come in handy. So we'll go ahead and divide. Give it a try if you haven't paused the video yet. 4 times 2 is 8. So we have 18. 4 times 4 is 16. 2 is a remainder, so no. It's not a multiple, there's a remainder. Okay. And last one here is 102 a multiple of 3? So go ahead and try. 3 times 3 is 9. 3 times 4 is 12. There is no remainder, so yes. 102 is a multiple of 3 because you can write 3 times 34 equals 102. Alright, so now that you have that background, go back to the boss question. Oops. See if you can solve it and write your answer on the math document.